Everyone. We are just going to wait for a couple more minutes and then we'll get started. My name is Devanshi Katari, and I'm the founder and executive director of an organization called Power Up with STEAM. So welcome to today's College and Career Talk, where we will be hosting a webinar / Q&A type session with Priyanka Bhatt. Priyanka is a director of data science at WIRB-Copernicus Group. She's had many different experiences with biomedical sciences and with data science in general. She majored in biochemistry in college and went on to pursue other biomedical studies degrees in future education, and has also gotten a PhD in data science. So for more information about the College and Career Talk, we will be going into more in depth about what data science really is, and then we will be going into some more in-depth questions about Priyanka's experience as a female in STEM. So be sure to stay till the end, because we'll provide you guys with many different resources on getting involved with data science or studying more about data science if you've never had any experience in general. And one important thing to note is please do keep your cameras and microphones turned off for a smoother recording of the event. If you guys have any questions at all, we will be getting to a Q&A sessions, as I mentioned earlier, after 20-30 minutes into this webinar. So be sure to type in any questions that you have, because we will be going over those and some other ones as well. All right, Priyanka, I'll let you take the stage.
Thank you. Let me go ahead and share my screen. Hey everyone, so happy to be here. I am Priyanka. I'm a bit of a nerd, so I ended up doing a PhD in health informatics, which I believe is a subset of data science. Post that, I did my dissertation in breast cancer genomics at NYU, School of Health Informatics and Bioinformatics. Post that, I joined a contract research organization called Covance. I joined there as data science lead in support of algorithm-driven feasibility, site selection, and investigator relations. Currently, I work at a company called WCG Clinical, or WIRB-Copernicus Group. We basically help speed up the process of clinical development to help bring drugs to market faster. And here I play the role of director of data science, as Devanshi mentioned earlier. And I'm tasked with bringing data together from all of our disparate sources and then building things using that data. So either building new data products or problem solving with the data that we have. And I work with all kinds of health data, public, proprietary, as well as licensed. Under the WCG umbrella are 28, actually more than that, 30 different independently operating companies. All of them generate a wealth of information. And it's my job to evaluate what's valuable and how we can monetize the information that we have. So I really enjoy my work, and I'm super happy to be here with all of you who seem to be interested in data science. So I think that makes us collectively a group of nerds. So thank you for joining. What is data science? That is a question that I love to hate, because data science is extremely broad. If I could use an example or a metaphor, saying that you're a data scientist is like saying you're a doctor. The next natural question is, what kind of doctor? Same thing with data science. You have the ability to specialize in certain things. So for example, you can be a machine learning scientist that is really great with predictive modeling. You could be a visualization expert, or you could be a stats person that just loves to make sure that we're doing math in the best way possible. So it's a very broad field. And you need to figure out for yourself what you really enjoy doing. Do you enjoy building things or asking the right questions? So why should you consider data science? A very good reason is that we have a lot of data. And the growth projection for data is astronomical. We're going to have lots of data going forward. We keep inventing new ways of collecting data. I wear an Apple Watch that collects data all the time. Your phone collects data from you. And we keep increasing the amount of data that we're collecting. We can use it to do amazing things. So that's definitely a reason to get into data science. A lot of the data that we have is yet untapped. So a lot of data, especially because I work in healthcare, I'll give you a healthcare example. EHR systems, doctors' notes are unstructured. There's no structure to them. They're unclean. They're sitting in disparate sources. And for that reason, a lot of that data is yet untapped, or it's not being used to its full potential. So there's a lot of work that can still be done. A fact for you guys, data-informed decisions just yield better outcomes. If you guys haven't watched the movie Moneyball, please watch it. It's a really good movie, and this is exactly where that fact comes from, right? It demonstrates why data-informed decision-making is extremely important. So if you don't use data in your decision-making process, you're pretty much at a competitive disadvantage. Data is the new currency. I don't know how many of you kept up with the news that Pfizer had made a deal with Israel, the country, where they said, we'll give you early access to our vaccinations if you provide us with data on all of your citizens. Now, this was definitely a controversial deal, but it occurred, and they were able to vaccinate quickly, efficiently, and provide all kinds of data. In fact, based on the data that Israel provided, we know that the Delta variant let me rephrase that. Because of that deal and because of the data that was provided, we know that the Pfizer vaccine is not as effective against the Delta variant. All of this was in the news, so it's really exciting to me that this is a first of its kind deal, and I'm sure that we will see more such deals in the future. But the most important reason for becoming a data scientist, according to me, is that it's cool. All the cool kids do it. I'm also saying this because I am pretty much calling myself cool here. But data science is everywhere. I mean, you pick up your phone and data science is there. You Google flight tickets and you have an algorithm telling you what the best time to buy flight tickets is. You have an algorithm at the doctor's office telling you if there are any delays. So data science is applied all over the place, and it's extremely important. And we're only now starting to realize the value of data science, the practical application of machine learning and AI. I think I dedicated a slide on this, in fact. So AI and ML are definitely the coolest parts of data science, right? Everyone always talks about artificial intelligence and machine learning and how machines are smarter than us now. That is never the case. We are still smarter than machines. In fact, if I were to talk about the practical use of ML, it's that machines are basically doing what humans can do, but at scale, right? So we can't process large amounts of data, and an algorithm can. So we build algorithms that can learn and process large amounts of data. That's really what AI ML is. Some of the applications that you guys might be aware of, self-driving cars. So there are companies that come up with all kinds of training data to teach cars to identify objects on the road and self-drive. Robotics, healthcare has AI ML applications, although there's always a human in the loop element to AI and ML in healthcare, right? Without human validation, it's sort of dangerous to use AI and ML for decision making. There's more fit for purpose data out there now. There are companies, in fact, that are coming up with synthetic data to reduce the amount of bias that exists in real data. So there's more data and we can use it to train all kinds of cool models. And we also have people with the right skills. I mean, if you specialize as a machine learning scientist or in deep learning, then you are definitely a very valued individual and you have like really great skills. So again, all of this to say that data science it has something for everyone, in my opinion. And there's still so much that is yet to be discovered. My advice to all of you is to make like Dora and be an explorer. And I say that because it's really important to find what your best fit is, what you like to do, and what you are good at. And in order to find what you like and what you'd like to do, you really need to learn and apply those skills. So I suggest getting an internship. It's great to reinforce the learning and also to test the waters and see whether that's something that you'd like to continue doing in the future. Also, don't be afraid to fail. It's an important part of the journey. There's a lot of learning that happens when you fail. So you can fail once, twice, 10 times, but get it over with so that you can start to succeed and you know what you don't want to do. Have a variety of interests. I think that this is super duper important. You absolutely need a diversity in perspective. It's beneficial not just to you, but also your future employer. My favorite time period when someone new comes to the company or joins my team is, that first 3 or 4 months when they can provide me with really, really great feedback and they can identify inefficiencies. They're not tied down to the process that we're currently using. So they're really great at, figuring out what a more efficient way of doing things is. And I love to talk to them and get their feedback. And that's it. That's it, really. So that's my advice to you guys. Explore, practice, find your jam, and enjoy data science. With that, Devanshi, can I hand it back to you?
Yeah, for sure. Thanks, Priyanka. That was a really good intro into data science and just like what it's like in general. Just a follow-up question for you. Would you be able to explain some of the terms that you use, like AI, machine learning, deep learning? Some people in the audience may not be familiar with some of these terms, and I myself recently have just learned what these terms mean as I continue my college interests and applying as a data science or a bioinformatics major. So would you be able to go into more in depth on what these terms mean and how they really relate to data science?
Yeah, absolutely. So ML is an application of AI. AI is just computers acting like human beings and doing things that humans can do. There are a lot of different subsets within AI. So you have machine learning, you have natural language processing, which is teaching a machine to interpret human language. So I'm sure we've all had a chat with a chat bot. If you go on any website and they have a chat button, it's really not a human on the other side. It's a machine that's interpreting your language, processing it, and responding accordingly. So there are various applications. I won't go into a lot of detail, but basically you're writing an algorithm, training it, writing an algorithm that can basically imitate the human process of thinking. So I'll give you an example. I'm kind of doing this on the fly and I'm thinking out loud here, so if I mess up, I apologize. But pretend like your brain is a machine learning algorithm, right? And if you want to teach it how, I've done this example before. I'm not going to go with it because I don't even remember. But basically, you have historical knowledge in your brain, right? So if I've been to the airport before 1 million times, and I know what the best time to go to the airport is, right? Maybe I went on a Saturday once and it was I was super delayed because there was a lot of traffic on the road. I went on a Monday evening and it wasn't as delayed. The roads were empty. I went one day when it was raining, and I know that when it rains, there's a lot of traffic. So there's a lot of historical data that my brain uses to train itself and to know to predict what the best time to go to the airport would be. So it sort of does this automatically, right? I don't even have to think about it. And my brain is using all the historical knowledge that I have and deciding when I should book my Uber for, right? So that's the same thing that a machine learning algorithm does. The curriculum that we teach it is historical data. So the better your data, the better your prediction. If you try, there's a phrase that data scientists use, it's trash in, trash out. So if you train your algorithm with the wrong curriculum or curriculum that is biased, then it's not going to make accurate predictions. So you're writing an algorithm telling the algorithm or teaching the algorithm how to think, providing it with training data, and then the algorithm does its thing. It sort of learns from its mistakes. I hope that answers your question.
Yeah, for sure. We had a really cool question come up in the chat. And it's, what is the future of data science? And based on your experience as someone who's worked in healthcare, someone who has a lot of different experiences, what do you think is the future of data science?
There's a lot of untapped data. So I'll speak to healthcare because I work in healthcare. There is a lot of untapped data, and we haven't even started leveraging it. Like EHR systems, claims data is used all the time, but there are a lot of gaps in using claims data. There's a lot of genetic data, genomics data that's coming up. There are companies that are using genomics data to predict whether or not to detect cancer early, for example, right? So there are some really cool applications, and we're just sort of on the cusp. I think the future of data science is making sure that our data is fit for purpose, right? That's really the rate limiting step at this point, because we have all the algorithms, we have the models. It's the data that limits us. And you can read about it in the news. There was one recent example where an AI algorithm was being used to make decisions, a decision like whether or not a patient would be eligible for a ventilator support, right? And the training data that was used to teach this algorithm turned out to be biased. So this algorithm was making biased decisions. It was recommending that rich white people get ventilator support, whereas minorities were being rejected. So there's always like at least for now, there's always a human in the loop element that is necessary, right? We need to validate and approve decisions that a machine makes. I think in the future, we'll get better at making those predictions, and we'll get better at reducing that bias in the data.
Awesome. So I know we have many aspiring data scientists in the call with us today, or maybe you are just learning about data science right now and are thinking about how to get started. So what technical skills do you primarily use as a data science? Is it a lot of programming? Is it a lot of research? What exactly entails a data science?
Yeah, great question again. So there are a lot of different programming languages, right? Again, I'll go back to saying that this is a really broad field, and you sort of need to figure out whether you want to specialize or whether you want to be more of a data science generalist. If you do want to be a generalist, I recommend being familiar with cloud computing, right? That is something that everyone uses. So be familiar with cloud computing. The most popular languages, according to me, are R and Python. I think I lean a little more towards Python or PySpark, but it's really your choice. And it also depends on whether or not the employer or the project that you're working on chooses to be code agnostic. A lot of companies do choose to be code agnostic, so you have the option of using any language you prefer. But I definitely recommend knowing either R or Python. SQL is a standard language that I think pretty much everyone should know how to work with databases and how to query data. BI tools like Spotfire, Tableau, again, super important to know how to visualize data as well. And then you should know how to ask the right questions. I think being critical of the data and asking the right questions is a really important soft skill to have.
Cool. Another question that came up in the chat was, as a high schooler, how important is it to learn more than one programming language? I know like many times in my life, people have told me that like once you know one coding language, you basically know all of them. Is that really the case for like data science as a field, or like as a high schooler, do you think that people should really get to know more than one programming language?
I mean, I think if you know one, you're set. But really thoroughly understand the concepts, right? So all the programming languages are kind of similar. I mean, I don't expect anyone, I personally don't even remember all of the commands, right? So you'll always be Googling for things. But just conceptually understanding programming and what you're doing with the data, I think is more important. And that should enable you to learn any new language quickly and efficiently.
Cool, yeah. When I was actually getting into data science, someone once told me that data scientists are the best Googlers. And when I personally was doing my research, I had to Google all sorts of things. So yeah, I completely agree with you, and I definitely understand exactly what you're saying, because there's absolutely no way that we could memorize everything that is in every package or every library of even one language.
Yep.
Yeah.
So
So moving.
data cleaning as well. You're basically like a cleaning person for data.
Yeah, exactly. So going back to something that you said earlier about having a variety of interests, as high schoolers, we're always pressured to, make decisions, choose which major you want to go into later, what do you want to study, what do you want to become. And I personally have struggled with that, and I know a lot of people in the audience might have struggled with that. So you have many experiences with different areas of science in high school, college, etc. So in your experience, how hard is it to really switch focuses among different areas of science and technology?
I don't think it's hard. I think it really depends on what your interest is. If you're passionate about what you're learning, then it's not hard at all. In fact, I found an intersection for both of my passions, right? I really enjoy healthcare, science, and technology, and I found my niche. This is where I wanted to work. So for me, it wasn't that difficult to make the switch.
Nice, that's good. Um, so you're currently pursuing a STEM career today. Were you a STEM girl in high school as well? Did you engage in different activities, different courses that really built your passion for STEM, or did you get more into it later on?
I like the term STEM girl, first of all. I pursue these things in high school? No, I'm sure many of you, or maybe you guys are just more focused than I am. I was pretty much undecided in high school. I didn't know what I wanted to do, and I had varied interests. Right, I was interested in business, in not really math. I hated math. It's funny because as a data scientist, you really need to know math. So I was interested in a variety of different things. I was definitely a science nerd, loved all of my science classes. And to be quite honest with you, I don't think I did any internships or anything while I was in high school. So at that point, I was pretty undecided, but I had done some technical classes and science classes that had gotten me super excited. So I knew where my interest lied.
Great. So when you got into college, what were some of your experiences in college, research projects, internships like? And if you remember, or even if you don't remember, if you could provide maybe some detail about how what a special project of yours was, and how it contributed to your growing understanding of science.
Yeah. So I did a couple of things. I was a TA for one of the courses that I liked in comp sci, and I did it because they say that teaching is a form of learning, and I firmly believe that. So I really enjoyed teaching others, and in some ways it was reinforcing my own learning. So that was one of the things I did. Research projects wise, not an undergrad, but when I was doing my master's, I chose to do computational research and not wet lab research. And I sort of proactively reached out to a lot of different professors that had labs and grant money so that they could support my learning. And I read a lot about them and the research that they were doing. And I tried to figure out how can I contribute to this? Is this something that I would be interested in? So I took the time to send those emails, have a conversation with each one of them, and then found a really great project in working with primary immune deficiency. So I don't know how much you guys know about primary immune deficiencies or PIDs, but these patients will typically show up with a variety of symptoms. And only after being hospitalized multiple times do they finally get a diagnosis, a correct diagnosis of a primary immune deficiency. So I used hospitalization data. I believe it was like an open source data set. And I came up with some sort of a scoring algorithm. So based on the number of hospitalizations and what diagnoses were being made on these patients, like what is the likelihood of them having a primary immune deficiency, just so they could catch it earlier. So that was one of the cool projects that I did. My PhD thesis, like I said, was in breast cancer genomics. So I learned the programming language Perl, Perl, which is, I'm told, one of the toughest languages to learn. So I'm pretty impressed that I did that just for my thesis. And I used a lot of regular expressions, worked with sequencing data, and tried to identify patterns in the expression of various subtypes of breast cancer. So those were my two cool projects that I did.
Nice. That sounds really interesting. So nowadays, like a lot of high school students want to get involved in research. I know that there's several opportunities.
Overachievers.
Yeah, true. But based on your experiences, how can students who want to get research experiences, how can they find these opportunities and how can they like go about them?
Yeah, find people that have a lab. Look up your local universities, or maybe not local, right? There are a lot of, so for example, I came across this recently. What do you call them? The Fulbright scholarship people. Like even if you're not a Fulbright scholar, they can still sometimes find you grant money to do research. So find companies that support research, find people that are working currently on data science projects at universities. They can always use the help and you can use the experience. So, don't assume that they wouldn't be interested in working with you. Make the connection and proactively reach out to them and see what they have to offer.
Nice. So transitioning into, being a female in STEM, right? Like we've noticed that technological areas, sciences have always typically been male dominated. So what was your experience like being a female in STEM? Were there any hurdles that you faced? And if so, how did you get past these hurdles?
No hurdles that I faced. I never thought of myself as, female in STEM. I was just, this is my field, right? This is what I do. I agree that, we are not a majority, but there are more of us now. There are more women in STEM, more women in computer science. And I haven't faced any hurdles personally. I think it's fantastic for women to pursue this because, I think we're like naturally analytical. And it's great. I support it.
Yeah, I think so too. Honestly, I think the part about like the mindset is super important. Like if you always think of yourself as a minority, like never gonna get the confidence to, like go forward. So I think that's a really good thing for you to say and just like some advice that you had.
Yeah.
So I think you mentioned this at the beginning of the talk as well, but what is your current role like? Could you maybe describe your like career trajectory, what you did after school, and how you got into your position right now?
Yeah. I don't know if I want to start at like high school, but I'll start at school. So after I did work when I was doing my master's thesis or my master's. I worked as a research coordinator. And the reason I kept working throughout, so I worked as a TA, research coordinator, I freelanced as a web developer. So I did all kinds of things just to get myself comfortable with, the work that I would be doing in the future, right? Like, is this where I really want to pursue? And then I did a lot of Googling on career paths. So I was interested in data science, and I wanted to know like what would a path in data science look like, right? So I would Google for job opportunities, and I'd just like read the job descriptions. So I'd look at those and figure out like what job description do I like and what's my ideal job description of the future, right? Like where do I want to go? And then a bit of it was also just luck, right? I found my calling in pharma. I didn't plan it. I didn't plan to be in pharma, but after I graduated from Rutgers with my PhD, I had the opportunity to join this company. And quite honestly, at that point, I was brand new to pharma. I had no idea how drugs were made, but I did it and I enjoyed it. So I guess something else that I'll add to my advice is be comfortable with being uncomfortable, right? Always push yourself outside of your comfort zone, because that's where real learning happens. And you'll surprise yourself. I mean, you might end up really enjoying what you do. So I really love what I do. I love that I help bring medicines to market faster. If you go to a pharmacy today and see a drug on a shelf, it's probably because there was a clinical trial that was conducted, and that drug was approved for that reason, right? And I'm helping run those clinical trials. And we've all just become super familiar with clinical trials because of COVID, right? Like we all know how these vaccine trials were conducted. So it is really important. And I wanted to stay within pharma. So I first joined a contract research organization. I now moved to a company that does more variety in the work, and they're more, I guess I'll give them a high compliment. They're sort of like the McKinsey of the pharma world, where they have a lot of proprietary data and they use it to make recommendations to sponsor clients. Did I answer your question?
Yeah, it's good. And you also kind of answered my last question as well, which was just like general advice or closing thoughts that you might have. But you did give really good advice about like, don't be afraid to, like be uncomfortable, because that's how learning happens, right?
Yep. I'll give you all one more. And this is, I guess, especially for the women, but really for everyone. Don't be afraid to say no. Everyone learns how to say yes, but we're rarely taught how to say no. I wasn't taught it, and I think that was a skill that I had to learn from my mentor at work. And I think it's a really, really important skill to have. So know how and when to say no. I'll leave you with that.
All right, thank you so much. So now I'm going to share my screen one more time. And here on my screen, I have 4 steps to become a data scientist. Now, not everyone's path will look the same, obviously. There's several people who like major in something different and then later realize that their calling is actually data science. But here's some tips that I myself put together after talking with Priyanka and just doing some more research on data science. And I know Priyanka mentioned that she studied biochemistry in college, which is not very a computer science or data science related field. So it's completely okay to have like a diversity of interests, and I know the future is becoming more interdisciplinary. So even if you do study something different, you always have options to go into data science. One thing I'll highlight between a conversation I had with someone who was in data science was that like if you didn't have like the technical knowledge of like biology or chemistry before you became a data scientist, it would have been very hard for this person to like be in the position that they are right now. So data science is super cool, but it's also super cool to be able to apply data science in different places as well. And with that, I know we already did some Q&A, but I'll open the floor to anyone who has any further questions to ask Priyanka. So we can just unmute or type the question into the chat if you have any questions. I'll wait like 30 seconds. All right, okay, tough crowd. That's okay. I'm pretty sure we did go into many of the very common questions already, so it's all good.
I have
If
a question.
Oh yeah, for sure, go ahead.
What's the difference between artificial intelligence and data science?
What's the difference between AI and data science?
Yes.
AI falls under data science. So AI is like AI is data science, is a part of data science. It's a specialization within.
Okay, thank you.
Yeah, great question. Any other questions? I think there are some technical difficulties. If you could just type your question into the chat, that would be great. I think there's a question in the chat about like being a doctor and leveraging data science. Do you have any additional thoughts to add on that?
Yeah, I'll give you another use case. So they're trying to come up with bots that, as you take a patient's history, will assist a physician in making a diagnosis. Now, again, we talked about how it's really hard for, I was just making sure I wasn't on mute. So we spoke about how it's really hard for humans to process large amounts of data, right? And the reason why you would want a bot like this is that they can process a lot of historically collected data from other patients, right? Process it in real time and suggest diagnoses.
Nice. That's really cool. Awesome. I think the person who was trying to ask a question earlier got booted from the meeting, which is kind of unfortunate, but hopefully they come back.
Wait, I have a quick question.
Sure.
So if you're like wanting to go into data science, would it be like advised or recommended to learn more about like AI since it's like a big upcoming subtopic in it?
Yeah, I think so. So even if you want to specialize in, say, visualizations, or if you want to stick to just working on data pipelines and data engineering, part of data science, I still think that it's good to know about these things, because you're right. It is, it is. I don't want to say it's the future, because it's the now, right? It's already in use, and we're just going to use more and more AI applications in the future. So absolutely recommend learning about AI and ML. ML is more the practical application. AI is just a cool term.
Great question.
Yeah, that was a good one.
All righty. Well, if we don't have any other questions, I'd like to thank you all once again for attending our talk. And since you guys all stayed till the very end, here are some resources that we can share with all of you guys about data science and how to learn more about data science. I know Coursera is always a very popular one, but feel free to take a screenshot of this slide so that you guys have references to the links and can check it out on your own time. So I'll give you guys about 10 seconds. I know these are all really cool websites that you guys can use to check out more information. But yeah, all right. So thank you guys so much for attending the College and Career Talk. So this College and Career Talk is through PowerUp with STEAM. As I mentioned, I'm the founder and executive director of PowerUp with STEAM, which is an organization that empowers girls with STEAM education. However, we do like everyone to attend our college and career talks, as you know, this information is super cool and super interesting. And anyone who's interested in something like this is definitely welcome to do so. So do check out our website, which is powerupwithsteam.org. And if you guys have any questions, comments, or just thoughts, just email powerupwithsteam@gmail.com, and we will get back to you. So that is all for today. Thank you guys all once again, and we will see you another time. Make sure to check out our website for more details about events. Bye, everyone.
Thank you. Bye.